What's up, guys? This is LeetCode counting bits, and it's an interesting question that builds upon the knowledge of a previous problem we've done. So if you haven't already, go and check out my video on LeetCode number of 1 bits, because that knowledge is foundational for this problem. And essentially this question is asking us to output an array of length n plus 1, where each element at each index corresponds to the number of 1 bits for that index. For example, this is index 0. 0 has 1 bits. This is index 1. 1 has 1 bit. Index 2 has 1 bit, etc. So the most obvious algorithm is to create an array, and it has 0 in it. And then we'll loop through for I in range 1 all the way to n plus 1. And we'll add to our result the number of 1 bits for that number. And then we'll return result. So we have to create this method now. So again, I'm assuming you've watched my other video on number of 1 bits, but essentially we get the count as 0 at first, and we say while n, and we do n and equals n minus 1, count plus equals 1, and we return count. All right, so this works, and it's pretty good because essentially we're doing n plus 1 iterations, and each iteration does this algorithm here, and this algorithm is in constant time. Technically it's O of 32 because we're using 32-bit integers, but that reduces down to O of 1. So it's O of n times O of 1, which is O of n. But we can do better than this, because if you notice, this algorithm looks at the result of the previous n and just adds 1 to the count. So it's almost like a recursive function. And instead of going top down, what we can do is we can flip it around and go bottom up. And we can use dynamic programming to make our algorithm much faster. So what we'll do here, instead of doing result.append self number of 1 bits, we're going to delete that. And what we'll do instead, we're going to get our result at I and I minus 1, and let's put this in parentheses, and then we're just going to add 1 to it. And so this will take the previous result that we've already calculated and just add 1 to it. And now this is still an O of n algorithm. It's just a faster O of n algorithm, because theoretically, worst case, each iteration of this could do 32 iterations here, and so it could be O of 32n, whereas here we're reducing that down drastically by using the previous result. And I just submitted, and we can see we were faster than 62% of online submissions. And that's all there is to it. So if you found this helpful, please give a like and a subscribe, because it really helps the YouTube algorithm. Leave a comment down below with what you'd like to see next, and I'll see you next time.